Hello everyone. In this video, we'll take a look at the concept of a contingency table. So let's say you have a group of students and the event. Okay, so there is a group of students called, let's say, group 1, and there is another group of students called, let's say, group 2. And we can say that there are two possible outcomes or events, that is success and failure. Okay, now number of students who belong to group 1 and who are successful, let's say, is A, and number of students who belong to group 1 and fail is, let's say, B. Number of students who belong to group 2 and succeed are, let's say, C, and number of students who belong to group 2 and fail are, let's say, D. Now, can I say that total number of students in group 1 based on this data, I can take a row wise total, that is total number of students in group 1 is A plus B, and total number of students in group 2 is C plus D. Similarly, I can take a column wise total and say that number of successful students is A plus C and number of failures is B plus D. Now let's do some very simple kind of probability calculations. Okay, so now what is the probability that given a pool of, what is the total number of students that we have over here? We have A plus B plus C plus D. That is the total number of students. So given total number of students as A plus B plus C plus D, if you randomly pick a student, what is the probability that that student belongs to group 1? Okay, so simple probability definitions will tell you that probability of particular student belonging to group 1 is A plus B, total number of students in group 1 divided by total number of students, A plus B plus C plus D. Okay, and let's calculate another probability value. What is the probability of a success? That is, what is the probability that you randomly pick up a student, okay, and the student that you pick up is actually someone who has, let's say, succeeded in the test. Okay, so for that, what you will do, you will take the total number of successes, that is A plus C, upon total number of students, that is A plus B plus C plus D. This is simple probability. Now, you must have studied the concept of independent events. Okay, so basically, when two events are independent of each other, okay, then the probability of A intersection B is equal to probability of A multiplied by probability of B, right? So, if I want to find out the probability that a student that I pick randomly belongs to group 1 and is a success, and if belonging to a particular group and succeeding is, there are two independent things, right? If they are independent, then what I can say is this should be equal to probability of belonging to group 1 multiplied by probability of being successful. Okay, so therefore this is equal to A plus B divided by A plus B plus C plus D multiplied by A plus C divided by A plus B plus C plus D. So when we multiply both these probability values together, the denominator will be A plus B plus C plus D squared. Okay. So now the next concept, this is the concept of independent events. Independent events. The next concept is that of expected value. Expected value. A simple unrelated example just to refresh the concept. Let's say if you say that probability of getting one head, probability that a coin turns out to be a head when you toss it is, let's say, 0.5. Then what is the probability that you get um so like, not the probability, because we are talking about expected value. So what is the expected, you can say, number of heads when you toss a coin, let's say 100 times. So what you do is you multiply n, that is the number of times you repeat the event, multiplied by p, that is the probability of a particular outcome in a single occurrence of the single repetition of the event. So n into p, right? So in this case, you will say it is 0.5 into 100. That is, you expect to get 50 hits. Okay. So now, if I want to say, okay, if I want to calculate, so what is the expected number of students who belong to group 1 and are successful? So that is given by, this is the probability value, right? So this probability value, that is a plus b times a plus c divided by a plus b plus c plus d square multiplied by total number of students, that is a plus b plus c plus d. So this cancels out. Okay, this will cancel out with one of these, and what you will have remaining is a plus b into a plus c divided by a plus b plus c plus d. Okay, so now if we observe the table, what this means is, this was our table. In the table, what we have observed is that the number of successes are a, right? And what is our expected number? This is our expected number. Okay, so I'll write it over here. This is the basic concept that will be required in the chi-square test calculations. What is the concept of observed value, which observed value in this case is just a, and expected value, but expected in the sense, expected when we assume that the uh, events, or let's say rows and columns, in this simple word, if you say rows and columns are independent of each other, independent. So in this case, belonging to a particular group and being successful or not, they are independent of each other. So this is our assumption. When we assume that the events, that is the rows and columns, are independent of each other, then the expected value is given by a plus b into a plus c divided by A plus B plus C plus D. Now, what is this? What is this? Actually, if you observe the table, it is nothing but the row total of that particular row multiplied by the column total of that particular row divided by the total number of elements. So the grand total, you can say. Okay, shall we verify this once in the table? Let's take a look. Okay, so as we have seen, when we are talking about this particular cell, okay, we are talking about this particular cell over here. Row total is A plus B, column total is A plus C. So A plus B multiplied by A plus C and divided by the grand total, that is A plus B plus C plus D. So that is how you calculate the expected value given the assumption that the events of the row and events of the column are independent of each other.